Dear students, good morning. This is the third module of lesson motion. In this module, let us learn acceleration and also solve some numerical problems related to velocity, speed, and acceleration. At the end of this module, you can define acceleration and also you can able to identify and utilize the formula for calculating the average speed, velocity and acceleration of an object in given situations. The first topic in this module is acceleration. In our last class, we discussed about velocity. So, what is acceleration? Acceleration is the rate of change of velocity with time. Any change in the velocity of an object results in an acceleration. That means acceleration is equal to change in velocity by time taken. So we can represent acceleration by small letter a and also the change in velocity. That means the difference of initial and final velocity. So we can substitute the final velocity first and initial velocity second. So the equation of acceleration is equal to v minus u by t. Here v is the final velocity and u is the initial velocity of an object. Suppose an object traveling with 5 meter per second velocity. We increase the speed from 5 meter per second to 10 meter per seconds in 2 seconds. So, in this case, our initial velocity, that means the first velocity of our traveling, that is u equal to 5 meter per second, and after increasing our velocity, that is the final velocity. So, v is equal to 10 meter per second. So we can apply these values in our formula. Acceleration is equal to v minus u by t. So which is equal to 10 minus 5 by 2 equal to 5 by 2, that is 2.5 meter per second square. So if an object travel in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then the acceleration of the object is said to be uniform. That means the first velocity of a car is 5 meter per second. Then it increases its velocity to 10 meter per second in 2 seconds. And again increase its velocity 15 meter per second in other 2 seconds. So we can say that the object is in uniform acceleration. That means the velocity is increasing in a regular manner and also the time taken is same here. Suppose a body decrease its speed in regular manner. For example, first velocity of an object is 20 meter per second, then reduce its velocity to 15 meter per second in 2 seconds. Then again reduced it to 10 meter per second in 2 seconds, like that. Here the velocity is decreasing in regular manner. That means first it is 20 meter per second, then again 15 meter per second and again 10 meter per second. Also the time taken is always 2 seconds. So the value of acceleration is negative in this case because the final velocity is less than the initial velocity. So we will get a negative acceleration here. We can say that when a body decreased its velocity in a regular manner, there is a negative acceleration is occur. This negative acceleration is called retardation. The other word for representing this retardation is deceleration or negative acceleration. So what is deceleration or retardation? Deceleration is always refers to acceleration in the direction opposite to the direction of the velocity. So deceleration always reduces speed. Next, we are going to solve some problems related to velocity, speed and acceleration. So first question is, a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. what will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? Here, given that the boundary of a square field, that means he can travel the boundary of square field in 40 seconds. The side of the square is 10 meter. So we must find out the perimeter of the square first. What is the equation of perimeter of a square? Which is equal to 4a. So 4 into 10 equal to 40 meter. And also total time is given here, that is 2 minutes 20 seconds. We should convert it into seconds. So 2 minutes means 120 seconds, and also plus 20, it is 140 seconds. So first 40 seconds he covered 40 meter, that means a perimeter of that square, and also next 40 seconds he covered 40 meter again, and again next 40 seconds he covered another 40 meter. That means the total distance after 120 seconds he covered is equal to 120 meter. So here the time is, total time is 140 seconds. So he used 120 seconds. The remaining is 20 seconds. So how many meters can travel using this 20 seconds? We know that 40 seconds he can cover 40 meters. So 20 seconds he can cover 20 meter. So now its position is, or his position is at C. So what is the displacement in this position? You can see that this AC represents the displacement of that person. How can we find out the displacement? This is a right angle triangle. We can use Pythagoras theorem to find out the displacement or the length of AC. We apply Pythagoras theorem, we will get root 200. What is the value of root 200? It is root 2 into 100, that means 10 root 2. So we can substitute the value of root 2 there, that is 1.41, and multiplied it, you will get the answer. The distance of AC equal to 14.1 meter. Moving to the next question, that is Usha swims in a 90 meter long pool. She covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight path. Find the average speed and average velocity of Usha. How can we find out the answer of this question? Here the total distance covered is 180 meter and the length of the pool is 90 meter, that is given in that figure. So average speed, we know that total distance covered by total time taken. Here the time is 1 minute, so we can convert it into seconds, that is equal to 60 seconds. We will apply these values in our formula of average speed, that is equal to total distance covered by total time taken. What is the total distance covered in this case? That is 90 plus 90, 90 for forward motion and 90 for reverse motion. Total is equal to 180 and the time is 60. So 180 by 60 is equal to 3 meter per second. That is the answer of our average speed. So what is average velocity here? That is equal to displacement by total time taken. Here the displacement is 0. What is the reason? Here initial and final position meets here. So what is our answer of average velocity? 0 by 60, that is equal to 0 meter per second. Our next question is related to acceleration. Starting from a stationary position, Rahul paddles his bicycle to attain a velocity of 6 meter per second in 30 seconds. Then he applied brakes such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. This is our question. How can we solve this problem? In the first case, the initial velocity u is equal to 0 here. What is the reason? The object is stationary position at first. So we can take u equal to, or initial velocity equal to 0, and it attained a velocity of 6 meter per second. That means 0 to 6 meter per second. So here the final velocity v is equal to 6 meter per second, and also time is there, it is 30 seconds. Then we will apply these values in our formula. A is equal to v minus u by t. So which is equal to 6 minus 0 by 30. That is equal to 0.2 meter per second square. So our first acceleration is 0.2 meter per second square. This is a positive acceleration. That means the speed is increasing here. In the second case, the initial velocity u is equal to 6 meter per second. What is the reason? The body is now traveling in 6 meter per second. So we can consider that is the initial velocity. And the final velocity v is considered after the application of brake. That is equal to 4 meter per second. And time t is given here as 5 seconds. We will apply this value in our equation. A is equal to v minus u by t, that is equal to 4 minus 6 by 5. So that is equal to minus 2 by 5 is equal to minus 0.4 meter per second square. What is the reason of this negative value? That means the velocity is reducing here. So the deceleration or retardation is occur here. That is the meaning of this negative sign. Students, please watch this video carefully and read your textbook thoroughly. Thank you.